Over the mountains of India, America gambled everything on an untested theory that a bomber could reach targets no aircraft had ever touched. On June 15, 1944, nearly 100 B-29 Superfortresses roared down runways toward Yawata, deep in Japanese territory, beyond the reach of any fighter escort. The longest bombing mission ever attempted, flown by planes making their combat debut. At 30,000 feet, Japanese flak punctuated the night as remote-controlled turrets swiveled, tracking every tracer round. Inside the pressurized cockpit, glowing engines groaned under the stress of the longest bombing mission ever attempted. The bomb bay doors shuddered open over Yawata's steelworks, releasing tons of high-explosive ordnance. The world was about to realize that nothing, not distance, flak, or fire, can forever remain beyond America's reach. Europe was convulsed in crisis. Germany had already annexed Austria, seized the Sudetenland, and then poured its armies into Poland, plunging the continent into full-scale war. Across the Pacific, Japan's military advanced incessantly through China, capturing city after city while tightening its grip on the region. The United States watched from across the ocean, its leaders increasingly aware that the distant conflicts might soon reach American shores. By 1939, military planners faced an urgent question. If war came to the Pacific, could the nation's existing bombers reach the far-flung islands and industrial centers of Japan? The B-29 Flying Fortress, America's pride in Europe, was formidable, but it had limits. Its combat radius was insufficient to reach targets deep across the Pacific. Its payload could also not guarantee the destruction of heavily defended industrial centers, and its defensive guns, while effective against conventional fighters, were no match for the projected threats Japan could deploy. If America were drawn into the conflict, it would require a long-range, fast, heavily armed bomber, capable of high-altitude flight over vast expanses of ocean. Witnessing the atmosphere at the time, Boeing began experimenting with pressurized long-range bomber designs, aiming to create something that would fly higher and farther than any aircraft in the Army Air Corps' inventory. Boeing executives, convinced of the technology's potential, bankrolled the venture themselves. From this ambition came the Model 334, a pressurized derivative of the B-29 Flying Fortress, featuring a nose-wheel undercarriage and a vision of the future. In April 1939, intelligence reports warned that Germany was mass-producing advanced bombers, capable of striking deep into enemy territory. Charles Lindbergh, America's most famous aviator, wrote urgently to General Henry H. Arnold after touring Germany and witnessing the surging Luftwaffe firsthand. He warned that, quote, "Germany is undoubtedly the most powerful nation in the world in military aviation, and her margin of leadership is increasing with each month that passes." This urged Arnold to prioritize a new bomber program, insisting the United States needed aircraft that could counter the threat. By December of the following year, the Air Corps issued a formal specification for a super bomber that could carry 20,000 pounds of bombs over 2,667 miles at 400 miles per hour. Boeing's Model 334 formed the basis of its proposal, refined into the Model 345 and submitted in May 1940 against Consolidated's Model 33, Lockheed's XB-30, and Douglas's XB-31. Lockheed and Douglas soon abandoned their designs, leaving only Boeing and Consolidated in the running. As a result, Boeing received a contract for 3 flying prototypes, plus a static test airframe, while Consolidated's design remained a backup. On September 6th, orders for experimental models from both firms laid the foundation of the very long-range bomber class. These would become the B-29 Superfortress and the B-32 Dominator. The program moved quickly. On May 17, 1941, Boeing received an order for 14 service test aircraft and 250 production bombers, later raised to 500 in January 1942. Boeing now had less than 2 years to deliver combat-ready machines, an impossible pace compared to the usual 5 to 10 years of peacetime development. Every delay risked leaving America unprepared, and every flight test was a high-stakes proving ground. At 141 feet, the B-29's wingspan was more expansive than any American bomber before it. It was the world's heaviest production aircraft at the time, a consequence of its enormous fuel load and massive bomb bay capacity. One of the most ambitious and complex features of the B-29 was its fully pressurized crew compartment, the first ever installed in a combat aircraft of its size. engineers at Boeing knew the Superfortress was designed to fly at altitudes above 30,000 feet, well beyond the range of most enemy defenses. At such heights, however, air pressure and oxygen levels made sustained operations nearly impossible. Previous bombers had to rely on bulky oxygen masks and left crew members exposed to extreme cold, fatigue, and frostbite. Designing a sealed, habitable environment inside a massive bomber was a challenge without precedent. The fuselage needed to withstand differences in pressure equivalent to several tons of force, all while remaining light enough to fly and strong enough to take combat damage. Boeing engineers developed an innovative solution: 2 pressurized sections, one in the nose and another in the aft fuselage, connected by a long, narrow pressurized tunnel that ran above the bomb bays. This allowed crew members to move between the cockpit and the tail gunner's position without depressurizing the entire aircraft. The engineering hurdles were immense. Every seam, rivet, and window had to be reinforced to prevent catastrophic leaks. Plexiglass panels had to be redesigned for both strength and clarity at high altitude. The pressure bulkheads, large domes sealing each crew section, were notoriously difficult to manufacture and often failed under stress during early tests. Boeing's engineers struggled for months to refine the materials and production methods before the system proved reliable. Manufacturing the B-29 proved just as daunting as designing it. This was not an aircraft that could be built in a single facility. To meet demand, the program relied on an industrial mobilization as vast as the aircraft itself. 4 main assembly plants, Boeing's Renton, Washington, and Wichita, Kansas facilities, Bell's Marietta, Georgia plant, and Martin's Bellevue, Nebraska operation, formed the backbone of production. Around them stretched a web of thousands of subcontractors, responsible for everything from landing gear struts to cabin panels. The sheer size of the B-29 complicated everything. Tail assembly stretched longer than many entire fighter aircraft. Wing spars arrived in rail cars, dwarfing the men guiding them. Fuselage sections and pressure bulkheads had to be fabricated separately and then transported for final integration, involving trains, trucks, and barges across the American heartland. The program demanded far more manpower than the existing pool of skilled machinists and toolmakers could provide. With millions of men in uniform, the industry faced a wartime labor crisis unlike anything before. Tens of thousands of new workers, many of them women, minorities, and people who'd never set foot in a factory before, were hired and trained on the job. For many, it was their first encounter with aircraft production. To accommodate this workforce, Boeing and its partners simplified assembly processes wherever possible, standardizing fittings, using pre-assembled subcomponents, and developing step-by-step instructions even novices could follow. Critical systems like engines, hydraulics, and flight controls still required skilled oversight, but the approach allowed production on an unprecedented scale. Bottlenecks often emerged around these components, slowing production and forcing constant adjustments to meet schedules. Among the many innovations built into the B-29 Superfortress, none captured the imagination quite like its defensive armament. Instead of a forest of manned gun stations, it employed a remote-controlled turret system that was, for its time, nothing short of science fiction. The aircraft mounted 4 remotely operated turrets, 2 dorsal, 2 ventral, each typically armed with twin 50-caliber M2 Browning machine guns. In total, a fully equipped Superfortress carried 12 50-caliber guns, plus a tail station housing either twin 50s or a 50 paired with a 20mm cannon. More than 10,000 rounds of ammunition were carried, about 500 to 600 per gun. At the maximum rate of fire, that translates to only half a minute of sustained shooting, making accuracy critical. At the core of the system was the General Electric Central Fire Control System. Each gunner sat inside the pressurized fuselage at an optical sighting station, equipped with a gyro-stabilized reflector sight. By tracking an enemy fighter, the gunner fed range and movement data into an analog computer, which automatically calculated lead, bullet drop, and relative motion. Servo motors slewed the remote turrets with precision, and any station could command multiple turrets or hand them off to another gunner as needed. This was a significant departure from earlier bombers, which relied on 10 or more crewmen in exposed positions. The B-29 reduced that number to as few as 5 gunners, all kept inside the pressurized fuselage. The system cut down on weight, improved crew protection, and allowed overlapping arcs of fire that could blanket the sky around a formation. Japanese interceptors, like the Nakajima Ki-44 and Mitsubishi A6M0, often fell prey to converging fire, with hits scored at 600 to 800 yards, ranges conventional turrets could not manage. The B-29's first flight came on September 21, 1942, at Boeing Field in Seattle. Veteran test pilot Eddie Allen lifted prototype XB-29 41002 into the air after years of design work. The aircraft handled well enough to suggest Boeing's ambitious vision was possible, but shakedown flights quickly revealed serious challenges. Early prototypes suffered mechanical and thermal problems, prone to overheating and catastrophic failures. On December 30, 1942, the second prototype erupted in engine flame mid-flight, but the crew was able to land safely. Tragedy struck on February 18, 1943, when Allen piloted another prototype over Seattle. Minutes after takeoff, the number 1 engine exploded. The B-29 shuddered, rolled, and plunged into the Fry meatpacking plant, ending the lives of all 10 aboard, 20 plant workers, and a responding firefighter. Structural issues compounded engine troubles. Pressurization, one of the B-29's hallmark features, created new stress loads on the fuselage that no American bomber had ever endured. Vibration and landing gear failures under the bomber's 140,000-pound gross weight also exposed constant engineering challenges, sending crews back to the drawing board after every flight. Most of the B-29's early troubles stem from its engines. The Wright R-3350 duplex cyclone radials promised unprecedented speed, altitude, and range, but early models were notoriously temperamental. Fires, valve failures, and overheating plagued the first production aircraft, making even short missions potentially catastrophic. To keep the aircraft in the sky, engineers devised a series of interim fixes: cuffs on propellers to channel cooling air, baffles directing airflow onto exhaust valves, increased oil flow, and asbestos shields for push rod fittings. Crews performed exhaustive pre-flight inspections to detect unsealed valves, and maintenance teams followed punishing schedules. The uppermost 5 cylinders were replaced every 25 hours of flight, and complete engine overhauls were often required every 75 hours. Delays were inevitable. Initially slated for 1943, testing setbacks and ongoing modifications pushed B-29 combat entry back nearly a year. To meet urgent operational needs, hundreds of brand new bombers were ferried straight from the assembly lines to a cluster of modification centers in Kansas. There, in the depths of winter, thousands of workers, mechanics, engineers, and factory hands set about bringing the fleet up to standard. Unfortunately, the B-29 was too large for most hangars, so much of the work was done outdoors on frozen tarmacs, where crews battled snow, wind, and temperatures that plunged below zero. They had to install new equipment, seal pressurized cabins, rewire systems, and debug the central fire control turrets. Around the clock, floodlights lit the rows of half-finished giants, their wings rimmed with ice, while men on ladders wrestled with panels and cabling. In barely over a month, between March 10th and April 15th, 1944, roughly 150 aircraft were transformed from half-finished prototypes into war-ready machines. After 2 years of trial by fire, the B-29 was still far from perfect, but it was finally serviceable. The price of its development had been high in time, money, and lives. Recognizing its potential, President Roosevelt endorsed a strategic pivot, using the B-29 to demonstrate U.S. support for China while projecting air power directly into Japanese-held territory. 4 forward bases were established in the Chengdu region and 5 in eastern India, providing staging areas for fuel, munitions, and maintenance. These installations formed the backbone of Operation Matterhorn, an ambitious plan to strike Japan from Chinese territory. Logistical challenges were staggering. No overland supply lines meant fuel, bombs, and even aircraft had to fly over the Himalayas, the infamous hump. Some B-29s were even stripped of guns or armor to carry additional fuel. On June 5, 1944, a formation of B-29s roared into the skies over Japanese-occupied Thailand. Navigating treacherous winds and unpredictable weather, they released their payloads over Bangkok, striking railway yards, power plants, and military installations. Even when crews followed the prescribed release points, the enormous weight and long fall time of the bombs made accuracy nearly impossible, reducing what should have been precision strikes to area bombardments. Just 10 days later, on June 15th, B-29 struck Yawata on the Japanese home islands, flying at altitudes beyond most Japanese fighters' reach. This marked the first American attack there since the Doolittle raid nearly 2.5 years earlier. Most bombers targeted the Imperial Iron and Steelworks, a critical node in Japan's war industry, but the attack quickly descended into chaos. One superfortress was shot down, 2 others were forced down or crashed, and only a single bomb struck the intended factory complex. This lack of accuracy would become a defining theme for the B-29 in the early months of Operation Matterhorn. At the time, the Air Force was employing high-altitude strategic bombing, a method intended to destroy critical targets like factories, water supplies, or bridges while sparing civilian lives. It had worked on the Western Front, but over Japan it faltered. Bombs routinely fell miles off target, buffeted by the jet stream, where winds above 30,000 feet had reached 250 miles per hour. The long flights over mountains and harsh weather also took a heavy toll. Engines overheated, hydraulics failed, and crews were forced to make emergency landings on improvised airstrips, steadily increasing the number of aircraft lost. It became clear that a more secure and sustainable approach was needed, one that would allow the B-29 to operate with full range, heavier loads, and reliable support. The fight against Japan demanded air power that could strike the home islands from far across the Pacific. The solution lay in the newly captured Mariana Islands, a chain of volcanic outposts that became the staging grounds for the United States strategic bombing campaign. Fierce resistance, including the naval showdown at the Battle of the Philippine Sea, slowed progress, but Saipan fell by July 9th, Guam and Tinian followed, and by August, all 3 islands were in American hands. Seabees raced to build airfields capable of supporting the massive B-29 wings. 5 major fields, 2 on Tinian, 2 on Guam, 1 on Saipan, each able to host 180 bombers. Unlike China, these bases were secure from Japanese ground attack and could be reliably supplied by sea. Tinian, with flat coral terrain, became the centerpiece. It allowed 2 colossal runways over 8,500 feet long, which could handle dozens of fully loaded superfortresses taxiing, taking off, and landing in near constant rhythm. Hangars, repair shops, and modification centers sprang up across the island to allow near-continuous operation. On October 28th, 14 bombers launched the inaugural combat mission against Truk. The first strike against Japan from the Marianas followed on November 24th, 1944, when 111 B-29s of the 73rd Bomb Wing descended on Tokyo. Bombs still occasionally fell off target, and aircraft returned with damage that could have grounded them. Yet each return, each successful strike, reinforced the B-29's growing reputation. Into the chaos stepped Major General Curtis LeMay, a bold and unorthodox strategist who refused to accept failure. He scrapped the high-altitude precision approach and ordered B-29s to fly lower, striking Japan's cities with incendiaries under the cover of night. Flying between 5,000 and 8,000 feet, crews targeted densely populated urban districts, where most light industry was embedded in residential neighborhoods. Precision was now measured by city blocks, not factory floors. The first test came on February 4th, 1945, over Kobe, where coordinated firebombs ignited uncontrollable infernos, consuming whole neighborhoods and industrial complexes. Crews could now deliver concentrated citywide damage, leveraging the bomber's range, payload, and speed, though mechanical failures, flak, and storms remained mortal threats. LeMay's low-altitude raids had revealed the aircraft's true potential. The night of March 9th to 10th, 1945, Tokyo became a hellscape. At low altitude, 334 B-29 Superfortresses sliced through the darkness, engines straining under the weight of incendiaries. Starting their run over the Shirimichi neighborhood, 279 aircraft released 1,665 tons of bombs, most of them 500-pound E-46 cluster bombs, carrying 38 napalm-laden M69 bomblets each. Some dropped on thin roofs, others on streets, but each ignited in seconds. Smaller M47 incendiaries spread jellied gasoline and white phosphorus with devastating effectiveness. The fires erupted almost instantly. Individual blazes emerged into an unstoppable torrent that whipped through wooden neighborhoods, twisted steel, and collapsed rooftops. Streets became molten rivers, carrying civilians in frantic flight through choking smoke. In a matter of minutes, tens of thousands were trapped, engulfed by a conflagration intensified by winds 17 to 28 miles per hour that fanned the flames into a raging inferno. The firestorm consumed 15.8 square miles, destroying over 267,000 buildings and leaving more than 1 million people homeless. Losses of life approached 100,000, and injuries soared past 125,000. Above, B-29 crews faced their own peril. Engines overheated, fuel ran dangerously low, and turbulence from the fires threatened to rip the aircraft apart. Some planes returned streaked with smoke and scorched from battle damage. Others vanished in updrafts, swallowed by the chaos they'd unleashed. This raid was the single most lethal air attack of World War II. It obliterated industrial districts, crippled light manufacturing, vital to Japan's war machine, and sent a shockwave through the Japanese command. The B-29's most famous missions were yet to come. For an unprecedented role, a select group of B-29s, known as the Silver Plate series, was extensively modified. The process began in June 1943, when Norman Ramsey Jr. of Los Alamos' E-7 group identified the Boeing B-29 Superfortress as the only aircraft in the U.S. arsenal capable of carrying atomic weapons. Although Britain's Avro Lancaster had a cavernous bomb bay and would have required fewer modifications, Manhattan Project Director Leslie Groves and USAAF Chief Henry Hap Arnold insisted on an American aircraft. The most critical change was the enlargement of the bomb bay to accommodate the long tubular Thin Man and the oval-shaped Fat Man. They also incorporated fuel injection systems and reversible propellers, which gave pilots better control during landings. To reduce weight, all defensive guns except the tail armament were stripped out, making the Silver Plates faster and lighter than regular B-29s. In August 1943, the USAAF and Los Alamos staff conducted drop tests at Dahlgren, Virginia, using a 9-foot scale model of the Thin Man bomb, as no aircraft could carry the full 17-foot design. The test bombs tumbled uncontrollably through the air, veering off course and striking unpredictably. They highlighted the critical need for extensive experimentation and refinement before the B-29 could safely and effectively carry atomic ordnance. By September, Groves and Arnold agreed to expand the program. No more than 3 B-29s were to be modified for the bomb project, and a special delivery unit would be formed and trained. With the program expanded and a dedicated delivery unit in place, crews began intensive training and preparation, familiarizing themselves with the unprecedented weapons and flight procedures. These months of meticulous work culminated on August 6, 1945, when Colonel Paul Tibbets piloted Enola Gay from Northfield, Tinian, on a 6-hour flight to Hiroshima. He was accompanied by 2 specialized aircraft, the Great Artiste, carrying instrumentation and necessary evil, commanded by Captain George Marquardt to document the mission. Pre-flight procedures were tightly controlled under Major General Leslie R. Groves, director of the Manhattan Project. After a rendezvous over Iwo Jima, Navy Captain William S. Deke Parsons armed Little Boy mid-flight, with Second Lieutenant Morris R. Jepson removing safety devices 30 minutes before arrival. At 8:15 a.m., the bomb detonated 1,968 feet above the city. Enola Gay remained intact despite shockwaves, demonstrating the precision and reliability of the modified Superfortress. 3 days later, Boxcar, piloted by Major Charles W. Sweeney, faced additional challenges. A faulty fuel transfer pump rendered 640 gallons of fuel unusable, yet the crew elected to proceed rather than risk handling a live Fat Man onto another aircraft. Delays at the rendezvous and cloud cover over the primary target, Kokura, forced a diversion to Nagasaki. Using a combination of radar and a brief visual opening, Sweeney and his crew released Fat Man at 10:58 a.m. local time. Critically low on fuel, the aircraft executed an emergency landing at Okinawa's Yontan airfield. As the massive aircraft touched down at over 150 miles per hour, far above normal landing speed, the crew fought to maintain control, veering perilously close to rows of parked B-24s. Boxcar finally ground to a halt, engine sputtering, with mere minutes of fuel remaining, thanks in part to the bomber's reversible propellers. Both aircraft are now preserved in American museums. Enola Gay at the Smithsonian's Stephen F. Udvar-Hazy Center near Washington, D.C., and Boxcar at the National Museum of the U.S. Air Force. The events not only cemented the B-29s as the aircraft that delivered the most damage to Japan, but also as the one that finally put an end to the war in the Pacific. By the late 1940s, the Soviet Union, eager to match the B-29's capability, embarked on a daring and ambitious program, reverse engineering the Superfortress. Several B-29s had made emergency landings in Soviet territory during World War II, unable to reach Japanese targets. Rather than return them, Soviet engineers meticulously disassembled each plane, examining every rivet, wire, and system. Every component was measured, reproduced, and adapted to Soviet manufacturing capabilities. Minor differences in materials, tools, and production methods forced constant innovation while remaining faithful to the original design. The result was the Tu-4, which matched the B-29 in size, range, and payload, with only minor deviations in engines, avionics, and armament. Soviet modifications focused primarily on what could be produced locally without sacrificing performance. Aluminum in the USSR came in different gauges, requiring extensive re-engineering, and Tupolev, the aircraft's manufacturer, replaced Boeing's airfoil sections with their own preferred designs. Soviet engineers powered the design with the Shvetsov ASH-73, an 18-cylinder radial engine derived from the Wright R-1820, comparable in power and displacement to the B-29's duplex cyclone radials. In 1947, the Soviets debuted both the Tupolev Tu-4 and the Tu-70 transport variant. Many later Soviet bombers retained tailgunner positions similar to those on the B-29. Despite these differences, the Tu-4's outward resemblance was uncanny. Even the cockpit layout and bomb bay dimensions were nearly identical, giving the USSR intercontinental reach. For the first time, the United States faced a peer adversary capable of projecting air power across continents. The Tu-4 spurred accelerated development of jet bombers, guided missiles, and radar defenses. It set off an arms race that would shape the next several decades and mark the USSR's first real move toward nuclear parity. With the conclusion of World War II, the B-29 Superfortress shifted from being a weapon of all-out war to serving as a flexible part of America's peacetime forces. B-29s delivered food and supplies to prisoners of war and war-torn regions, demonstrating their adaptability beyond combat and cementing their reputation as workhorses of the sky. When the Korean War erupted in 1950, the B-29 returned to combat under a very different set of circumstances. Initially employed in conventional daytime strategic bombing, the Superfortress quickly destroyed the limited industrial and military infrastructures of North Korea. However, the sudden appearance of Soviet MiG-15 jet fighters forced a major tactical shift. After the loss of 28 aircraft, B-29 raids were primarily restricted to night operations, focusing on interdiction of enemy supply lines, transport networks, and bridges. The bomber also deployed advanced guided munitions, including the 1,000-pound BB-3 Raison and the 12,000-pound BB-13 Tarzan, for precision attacks against major bridges, dams, and other critical targets. Throughout the Korean conflict, B-29s flew approximately 20,000 sorties, delivering nearly 200,000 tons of ordnance. Crews demonstrated adaptability under threat, credited with shooting down 27 enemy aircraft, including a MiG-15 on December 6, 1950, even as 78 bombers were lost, 57 in combat, and 21 to other causes. The final B-29 mission of the war was flown on July 27, 1953, by a Superfortress of the 91st Strategic Reconnaissance Squadron, closing the aircraft's active combat chapter in Korea. Through operational versatility and symbolic power, the B-29 bridged the gap between World War II propeller-driven warfare and the jet-powered strategic air doctrine that defined the early nuclear era. Even as the Convair B-36 relegated it to a medium bomber role, the design progressed in the form of the B-50. This improved derivative and its many variants extended the aircraft's service life. The RB-50 flew reconnaissance missions, the WB-50 charted global weather, the KB-50 provided aerial refueling, and the SB-50 supported air-sea rescue. These adaptations kept the B-29 family relevant well beyond conventional bombing. Its very presence compelled adversaries to account for the threat of rapid, long-range strikes, spurring advances in jet interceptors, radar networks, and air defense systems. Even after jet bombers like the B-47 and B-52 assumed the nuclear strike mission, the Superfortress continued to prove its value in intelligence gathering, strategic projection, and logistical support. By the time production ended, the program had consumed over $3 billion, making it the most expensive single-weapons project of the war, second only to the Manhattan Project.